Hi, let's go through a small animation related to our project, Bike Sales Data Analysis.
Hi, I am looking for a bike for daily commute. I just live down the street.
Oh, sure. I have a perfect cycle for you. It has 21 gears, and it is aluminum type.
Perfect. What is the cost?
It is $200.
It is little expensive for me. Can you show something which is economical?
Okay, what if I give it for discount of $15?
Actually, I don't require gears. The route I travel daily has neither uphill or downhill. So, do you have any other bike which is neither aluminum type and has no gears?
Actually, the gears are in fashion nowadays. I don't have any non-gear cycles right now. What if I give you for more $15 discount?
Sorry, it won't be possible for me. No problem, I will look for something else.
Hope you are doing good. I am Jaydeep Patel with my teammate Bhavya Mistry would like to present our data visualization project on bike buyers data analysis. So what motivated us? Sharing our personal experience, when we came to Bloomington in this August, we visited Bloomington Bike Project Place where there were many bikes which were sold at cheaper rate and also recycled for sustainable environment. When we had a talk with the owner of the place, he mentioned that they were not able to sell the bikes efficiently. There were multiple reasons which motivated us to analyze bike sales. Firstly, as we know, many countries have excellent commutes for bikes, but still citizens prefer using their personal cars and buses, etc. We can reduce carbon emission and improve the traffic conditions by using bikes, and also people can maintain their health. When we thought of what is stopping the customers from not buying more bikes, we came to know that there are multiple problems which are faced by bike sellers while selling the bikes. We wanted to analyze how sellers can improve sales using the customer's dataset.
So, in order to improve the sales of business, it is vital to understand and identify the customers correctly. In this project, we have visualized the data of the people who have purchased the bikes in the past. By studying the trend of the dataset, we can help the bike sellers to target the right customers and recommending the bikes accordingly, and thus increasing the sales of the bike. Why is it important? As we can infer multiple analysis from the data visualization, such as that bike vendors can easily identify the key selling product of the inventory and stock them accordingly. Sometimes the stores are located in remote areas, so it becomes difficult for citizens to travel to the bike stores for maintenance. Thus, with the visualization, we will see whether distance affects the decision of the customer to purchase a bike or not. And by improving the bike sales, it will help the local vendors to improve their revenue. With more bike sales, we are eventually helping the environment and people. As more people use bikes, their body remains fitter and thus has less health complication, also less carbon emission, low pollution, thus reducing the global warming. Coming to the data set. So in our data set, there are total 13 variables where 5 are numeric and 8 are non-numeric. So the 5 numeric namely are ID, income, children, cars, age, and the non-numeric data types are marital status, gender, education, occupation, home owner, commute distance, region, and also whether a person has purchased a bike or not.
So coming to the technologies, we have used pandas to load, analyze and manipulate the dataset. NumPy has been used for mathematical operations, and we have used matplotlib to improve the GUI, and we have used Seaborn for some complicated visualizations. To make a Jupyter notebook interactive, we have used IPy widgets. So let's have a look at some visualizations. There were many visualizations available on the internet regarding bike sales and whether the person has purchased the bike or not. Here is one of the visualization. There were few issues with this plot, such as it was not clear to understand and the type of the plot chosen was not great. Also, the color chosen is not colorblind friendly. Further, I would like to mention one more visualization. In this plot, it gets very difficult for us to compare on the basis of age because of the scale used, and it is difficult to read the plot due to the cluttered markers of the scatter plot, creating occlusion and eventually misleading people.
So coming to the novelty of our work, while referring to the dataset on Kaggle, we came across many visualization in which some were misleading and some visualization lacked the interactiveness. So we tweaked them and plotted the visualizations which were easy to understand and made them interactive. We cleaned and filled in the missing values in the dataset and dropped the columns which were not required. We used IPI widgets to make the plots interactive and added a field where we can toggle the regions or values to compare the visualizations side by side. At the end, we were able to get the insights on what condition does the person will buy the bike or not.
The methodologies we have used for this project is: first, we searched and collected the data which is accurate and has enough parameters for visualization. Before any data is being used for visualization, the raw data goes through the data cleaning and it is processed for analysis. The cleaning includes detecting outlier and unusual groups, identifying trends and clusters, and did exploratory data analysis. And the data processing includes spotting local patterns, evaluating outputs, and presenting the result.
Coming to data correlation, in order to find the correlation between the columns, we plotted a heat map to understand which columns are useful and which aren't, which will be dropped and which will be help us to predict the user which will purchase a bike. For example, some column like ID when paired with others, the correlation is comparatively less, so even if we drop then it won't be an issue. Next, in the box plot to the right, in order to check which columns having numeric values contain any outliers or not, we can infer from the box plot that the income attribute has 3 outliers in which it lies in the range of 150,000 to 170,000. Whereas in the cars attribute, we found that there existed one person in the dataset who was having 4 cars, and for the children columns there are no particular outliers, whereas for the column age there are 3 outliers belonging in the range 78 to 90. Coming to the next visualization plot, this is a bar plot of the commute distance versus the percentage of the people who purchased the bikes and who didn't. For consideration, we have set the region to North America. Analyzing the plot side by side, we can conclude that most people living nearby in the range of 0 to 1 and 2 to 5 miles of the shop are most likely to purchase the bike, and commute distance more than 5 miles, there are very less chance that a person will buy the bike.
This is the beast form plot for the age of the person and the bike purchased. This is an interactive plot where we can easily toggle the regions to analyze the visualization region wise. This plot gives us the insight that the people buying bikes are might be more health conscious between the age of 30 to 40 years, and there are more bikes purchased there. After the age of 40, there are less people tending to purchase the bike. In this count plot, we plotted the graph for education of the people and whether they have purchased bike or not, and we have inferred from that the plot from North America that there are equal number of bachelors who bought bikes and there were very few people around 40 who did partial high school and were owing the bike. For Europe, maximum people owing the bike had completed their bachelors and there were least from the partial high school around 10 people. And in this specific region also the maximum bikes were owned by the bachelors and the least bikes were owned by the partial high school education people.
So the next plot is the KDE plot where we have used for different occupations and their earnings, and we have interacted with the people purchasing the bike. According to the plot, North America indicates that there are maximum people with the clerical occupation purchasing the bike, followed by the manual and skilled manual occupations. The least type of occupation who are not purchasing the bikes are professionals and the management people. For Europe, we can see that professional and skilled manuals earning around 50,000 to 100,000 purchasing the bikes are maximum, whereas management occupation people are the least who bought the bikes, and this is the same case for the Pacific region. And the last plot, this is the histogram with the KDE distribution for the people who purchased bikes which were married or single, with whether they were owning a house or not, which gives us an insight that the people who are married and who own a house in North America have maximum purchase of a bike, and the people who are married and don't own the house have least number of bike in all the 3 regions. So the above plot can be clearly understood by comparing it with the plot to the right, depicting the people who didn't purchase the bike, as we can just change or toggle them. So at the end, there are multiple conclusions which we came to by doing this project regarding bike sales with respect to the customers, such as we got the information about who purchased more bikes and what kind of profession with what range of income. and what impact does a person having a car creates on the purchasing the bike. And thus to sum up, we can say that this information can be useful for a seller to improve the bike sales. Thank you.